In this video, we'll look at some applications of linear equations that involve mixtures or tickets. In the first problem, we're looking at a coin type question. Diana has been saving nickels and dimes. She opened up her piggy bank and determined that it contained 48 coins worth $4.50. Determine how many nickels and dimes were in the piggy bank. The first thing we're going to do is just gather the information. So we have 48 coins, they're nickels and dimes only. We know that together they're worth $4.50. We just don't know how many of each coin we have. So we need to write one equation with one variable that represents this situation. So we're going to take one of the coins and let it be an unknown value. So let's let our unknown value be the number of nickels. So n will be the number of nickels. Then we need to represent the number of dimes with an expression, but that expression has to contain the same variable n. So we know that there are 48 coins in total. So let's say, for example, we had 10 nickels. We would then know that we had 38 dimes because they would have to total up to 48. So however many nickels I have, if I do 48 minus the number of nickels, that would tell me how many dimes I had. And you could do the same thing and let the dimes be the unknown and find the number of nickels by using that expression. It doesn't make a difference. So we're going to use that information to write an equation. The equation is going to be using the second piece of information, the value of the coins that we have in total. So in total we have $4.50. We know that nickels are worth 5 cents and dimes are worth 10 cents. We need to make sure that we write the money in dollar form, so decimal form. So our equation can kind of be set up in words first. So the value of the nickels, so that means the monetary value of all the nickels combined, plus the value of the dimes, should equal $4.50. I'm just omitting my dollar sign there. To find the value that we have in nickels, I'll take the value of 1 nickel, 5 cents, and multiply it by the number of nickels, which we have represented as n. To get the value of the dimes, I'll take the value of 1 dime, which is 10 cents, and then multiply that by the number of dimes that we have, which is this 48 minus n. And we need to write that 48 minus n in parentheses, because I would need to have to know how many dimes I have first before I multiply by the value of 1 dime. Notice again I have a decimal point, so for 5 cents it's 0.05, for 10 cents 0.10, or simply 0.1. This combined gives me $4.50. So I could go ahead and solve this equation. If I wanted to, I can clear out the decimals in this equation. It's very similar to what we do when we clear out fractions by multiplying by something. I want to multiply by something that will move my decimal point 2 places to the right, so that I no longer have 0.05, but I have 5. And the number that would do that the most easily would be 100. So I'm going to multiply my entire equation on both sides by 100. You don't have to do this. It's perfectly fine to work with the decimals, but it just kind of, I think, visually helps to clean up your equation as well. When I multiply by 100, all that does is move my decimal point 2 places. So this becomes 5n plus 10 parentheses 48 minus n equals, instead of $4.50, I have 450. So essentially I've written everything in terms of cents instead of in terms of dollars. So I'll just solve this as I would any other linear equation, clear the parentheses. So multiply by 10 here and here, 5n plus 480 minus 10n equals 450. Combine like terms that are on the same side, so 5n minus 10n is negative 5n, plus 480 equals 450. subtract 480 from both sides. So negative 5n equals negative 30. Just continue over here on the right. Just rewrite that last line, negative 5n equals negative 30, and then divide by the coefficient negative 5. Now we talked about reasonableness, so you should not only check your answer for accuracy, right? Did I multiply, did I divide correctly, but does that answer make sense? In this case, we're looking for the number of coins, so it makes sense that my answer is some sort of whole number. It's not negative, it's not a fraction, it's not a decimal. So n is 6, which means I have 6 nickels. And to find the number of dimes, I would subtract 6 from 48. If you write these statements, you could always just go back to these statements. So n is 6. So 6 equals the number of nickels. 48 minus 6 is 42. That's the number of dimes. So I've answered the question by filling in those definitions. In the second example, we have something similar, but instead of coins, we have tickets. During her shift at the museum ticket booth, Leah sold 115 tickets for a total of $1,163. Adult tickets cost $12 and student tickets cost $5. How many adult tickets and how many student tickets did Leah sell? Okay, so here I have gathered the information. So there are 115 tickets in total, and the value was $1,163. We know that the adult tickets cost $12 and the student tickets cost $5. We want to know how many of each were sold. So very much like the coin problem, we want to start with one of the quantities that we're looking for and let that be our variable. So I'm just going to pick adult tickets, and I'll use A to represent the number of adult tickets. Remember that a variable represents a quantity. So A really represents the number of them, how many of them. It doesn't represent adult tickets. Adult tickets is a noun. We want some sort of quantity, some sort of number. If we have 115 tickets in total, the number of student tickets can be found by taking the 115 and subtracting the number of adult tickets. So 115 minus A is the number of student tickets. I'll just abbreviate tickets there. All right, so now we can take the value of each ticket into consideration. The adult tickets are $12 each. So 12 times the number of adult tickets plus the $5 times the number of student tickets. The number of student tickets is the expression 115 minus A. That should equal the total of 1,163. So I don't have any fractions or decimals to clear here, so I could just go ahead and start solving by distributing 12A plus 575 minus 5A equals 1,163. Combining like terms, 12A minus 5A is 7A plus 575 equals 1,163. Now start to isolate the variable. So I'm going to subtract 575 on both sides. That's the addition principle, make that a 5. 7A equals 588. And then divide by the coefficient 7. Again, keep in mind reasonableness. The number of tickets, I expect a whole number. And I do get that. In this case, A is equal to 84. So there were 84 adult tickets sold. And if I needed to get the number of student tickets, I would subtract the 84 from 115. And 115 minus 84 gives me 31 in total. So 31 student tickets and 84 adult tickets. Again, just verify that if you add those together, you should get 115, and you could even do a quick check by multiplying each of those by their respective values and totaling that as well.